Welcome everyone. Today, we'll discuss corrosion under insulation, or CUI, and how to manage it effectively. This is a critical topic for industries like oil, gas, petrochemical, and power generation, where insulated equipment is common. Our session will cover what CUI is, why it matters, risk factors, prevention strategies, inspection techniques, and a structured management workflow. We'll also look at best practices and a case study. Corrosion under insulation or CUI is a major integrity threat in industries such as oil and gas, petrochemical, and power generation. This presentation will provide a comprehensive overview of CUI, its causes, risk factors, prevention strategies, inspection techniques, and management workflow. The goal is to equip engineers and asset managers with practical knowledge to mitigate CUI effectively and ensure long-term reliability of insulated equipment. The agenda includes: Number 1, understanding CUI and its significance; Number 2, identifying risk factors and high-risk areas; Number 3, prevention strategies and insulation design; Number 4, inspection and monitoring techniques; Number 5, risk-based inspection or RBI approach; Number 6, CUI management workflow; Number 7, repair and mitigation practices; Number 8, documentation and continuous improvement; Number 9, case study and lessons learned; and Number 10, best practices summary. First, let's understand what CUI is and why it's critical for asset integrity. CUI refers to localized corrosion occurring on the external surface of insulated equipment due to moisture ingress beneath insulation. It typically affects carbon steel and low-alloy steels operating within -4 degrees Celsius to 175 degrees Celsius, where water can exist in liquid form. Moisture enters through damaged jacketing, poor sealing, or condensation, creating an environment conducive to corrosion. Understanding this mechanism is crucial for implementing effective preventive measures. CUI can lead to severe structural damage, leaks, and catastrophic failures, resulting in safety hazards, environmental incidents, and costly downtime. Repairing CUI damage often requires insulation removal and extensive maintenance, which is expensive and time-consuming. Therefore, proactive management of CUI is essential for asset integrity and operational reliability. Next, let's look at what makes equipment vulnerable to CUI and where it commonly occurs: CUI risk factors and high-risk areas. Risk factors include operating temperature within the CUI range, carbon steel material, outdoor exposure, and cyclic temperature changes. Environmental conditions such as humidity, rainfall, and chloride contamination also increase susceptibility. Equipment with damaged insulation or poor sealing is particularly vulnerable. Common high-risk areas include elbows, pipe supports, low points where water can pool, and regions near steam tracing. Horizontal piping and vessels exposed to weather are especially prone to CUI. Identifying these areas helps prioritize inspection and maintenance efforts. Now, let's discuss how to prevent CUI and how to inspect for it effectively: prevention strategies, inspection techniques. Preventive measures include applying high-performance coatings such as epoxy phenolic before insulation, using water-repellent insulation materials, installing vapor barriers, and ensuring proper sealing at joints and penetrations. Stainless steel jacketing and adequate drainage paths further reduce water ingress and minimize CUI risk. Inspection methods include visual checks after insulation removal, ultrasonic thickness measurements through insulation, radiography, and infrared thermography for detecting moisture. Risk-based inspection or RBI helps prioritize areas based on probability and consequence of failure, optimizing inspection resources. Managing CUI requires a structured workflow, repair, and effective mitigation strategies. The workflow includes: Number 1, risk assessment to identify vulnerable assets; Number 2, inspection planning using RBI principles; Number 3, field inspection with NDT techniques; Number 4, data analysis to calculate corrosion rates; Number 5, mitigation actions such as repair and insulation replacement; Number 6, documentation in asset integrity systems; and Number 7, continuous improvement through lessons learned and updated strategies. Repair involves removing wet insulation, cleaning corroded surfaces, applying protective coatings, and installing new insulation with improved sealing. Long-term mitigation includes upgrading insulation systems, implementing periodic inspections, and training personnel on CUI awareness. Documentation and continuous improvement are key to sustaining a successful CUI management program, case study, and best practices. Maintaining a CUI management program with detailed asset registers, inspection history, and corrosion data is essential. Continuous improvement involves reviewing mitigation effectiveness, updating RBI models, and incorporating new technologies for monitoring and prevention. A real-world case study demonstrates how inadequate insulation sealing led to severe CUI damage, requiring costly repairs. Lessons learned emphasize the importance of proper insulation design, regular inspections, and proactive maintenance. Best practices include using stainless steel jacketing, avoiding insulation on equipment below dew point, and training staff on CUI risks. To summarize, CUI is a serious threat, but structured risk management, preventive measures, and continuous improvement can control it effectively. CUI is a significant threat to asset integrity, but it can be managed through a structured approach involving risk assessment, preventive measures, effective inspection, and continuous improvement. Implementing best practices ensures safety, reliability, and cost efficiency.